Hello students, welcome back to our channel Deeksha Karnataka. So as you all know, we have started the mock test for your COMEDK 2024 examination. So the first mock test was released on 29th of April. I hope all of you have downloaded the question paper and have started solving the paper. So in this video, I'll be discussing the part 2 of the chemistry solutions. So in my previous video, I have discussed the first 30 questions, that is from question number 1 to question number 30. And in this video, I'll be discussing from question number 31 to question number 60. Okay. So I want everyone of you to please see the video completely and understand each and every solution. And also if you are able to solve these questions, you can get a confidence that you are well prepared for the exam. Okay. So let us start with the first question. Okay, one more information here. The question paper PDF, if you haven't downloaded yet, is available in our WhatsApp channel. And the link of the WhatsApp channel will be there in the description section of this video. Okay. So please go to the description section, go to the link, then download the question paper, attempt it, and then come back to see the solution. So please do not see the solution without attempting. Okay. There's no point of just seeing the solution without practicing or without attempting the mock test. Okay. So that is my request. So let us now start with the first question. So the question is, the semi-carbazone is formed when an aldehyde or ketone reacts with. Okay, one second. Yeah, so the question here is, the semi-carbazone is formed when an aldehyde or ketone reacts with. So the question is from aldehydes and ketones chapter. Okay, so most of these questions are your previous year questions, so you will be able to know what type or what level of questions are asked from the from a particular chapter. So semi-carbazone, it is from your ammonia derivative. So this is your NH2, NHCO, NH2. So the question or the correct answer for this question is option number D. Okay, direct question from your ammonia derivatives, addition of ammonia derivatives. Okay, so here is another big announcement for all of you, as all of you requested for COMEDK mock test series. So we have started 3 mock test series which are absolutely free. So the first mock test has already been released on 29th April. So there are other 2 mock tests are still there. So you have to attempt this mock test, you have to join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So please go there, download, and in the WhatsApp channel you will be also getting the PDF of the solutions and all the updates about the about all videos that are coming related to your COMEDK. All updates will be there in the WhatsApp channel. So please join it. The link is there in the description section. This is very, very important and it will be very helpful for your preparation. Okay, so please join it. So all the 3 mock tests you must attempt. Okay, so let us now go to the next question. A first order reaction is half completed in 45 minutes. How long does it take for 99% of the reaction to be completed? So the question is from the chapter chemical kinetics, right? And we know one very important relation, T99.9 is equal to 10 times of T50. Right. So here the half-life is given 45 minutes. So T99.9 will be 450 minutes. Now if you want to convert it into hours, so we'll get 7.5 hours. The correct answer for this question is option number D. Okay, very easy question. So I hope all of you will be able to do this question correctly. Now question number next 33, which is the end product in the following sequence of the reaction. Okay, so COCH, first you have C, the OOH, that is your benzoic acid. Now when you treat it with PCl5, what will happen? This OH group will be replaced with your Cl group, right? And then when you treat with NH3, then again what will happen? This is my this is my P. Now when you treat it with NH3, so what will happen? This one will be converted to C double bond O NH2 group. Right. Now when bromine KOH is there, that is your Hofmann bromamide degradation, this part will be eliminated and we will get NH2 group here. Okay, so the correct answer for this question will be aniline, that is option number A. Okay, very easy question. So this question you can tell from your acids chapter, acids reactions and amines reactions. So in organic chemistry you will get a mixture of questions, like one reaction from this chapter, one reaction from other chapter. So that is why you should be very, very thorough with all the reactions that are present in your organic chemistry. Okay, next question number 34. In the reaction, this one H2O2 acts as. Okay, so first let us see what is the oxidation state of Ag here. So if you see Ag is 2x minus 2 is equal to 0. So x is equal to plus 1. Okay. and here it is 0. So plus 1 to 0, Ag is undergoing reduction, so it will behave as an oxidizing agent. That means this one must be undergoing oxidation and it will behave as a reducing agent. So the correct answer for this question is option number A. Next question, match the following. Column 1 and column 2 is given. Okay, so this question is from your, I think, biomolecules chapter. Okay, so peptide linkage is connected to proteins, right? So A should be 3, so we have only one option with A is equal to 3. Then nucleic acid is connected to nucleotide, so B is 4. Hydrolysis of cane sugar is inversion, so C is 1. And starch is a polysaccharide, D is 2. So the correct answer for this question is option number C. Very easy one. I hope everyone would have done correctly this one. Then question, another match the following is there, again column 1 and column 2. So this time it is with your, this is from your D and F block chapter. Okay. So now mic metal, if you know, it is an alloy of lanthanoid metal. So A should be 2, right? So A should be 2 is only one option. Then Ziegler-Nattler catalyst is your TiCl4 and aluminium. So that is your B equal to 3. Then brass is your alloy of copper and zinc. So C is 4. Bronze is an alloy of copper and tin. So D is 1. So the correct answer for this question is option number B. Okay, very easy question. Next, given below are few mixtures formed by mixing two components. Which of the following binary mixtures will have the same composition in the liquids and vapor phase? Okay, so if you see here, same composition in the liquid and vapor phase means that is your azeotropic mixtures, right? And azeotropic mixtures are formed by non-ideal solutions, right? So the question is from which topic? If you know, very important high weightage topic, that is solutions chapter. Okay, 3 to 5 questions definitely will be getting from this part. So very, very important. So ethanol and chloroform, benzene and toluene, nitric acid and water. Now if you see here, ethyl chloride and ethyl bromide. So this one will form a ideal solution, right? And benzene and toluene will also form a ideal solution. So we are left with 1 and 2. So 1 and 2 is in option B. So the correct answer for this question will be option number B. So 1 and 2 will form non-ideal solutions and they can have any type of azeotropic. It can be maximum, it can be minimum also. Next, under drastic conditions, all the alcohols can be oxidized to carboxylic acid, but which of the following alcohols give carboxylic acid having the same number of carbon atoms? So this question is from your alcohols, or you can also be from the acids kind. Right? So if you know, primary alcohol will always give you the same number of acid. Okay, there is no CC cleavage, bond cleavage is not there. So the correct answer for this question will be option number A. Okay, secondary alcohol will give you first ketone, and then if you further oxidize it, it will give you acids, but the number of carbons will decrease. Tertiary also same. So the correct answer here is primary. Okay, easy question. Next question 39. Which of the following alcohols will give the most stable carbocation during the dehydration? So let us see the carbocation order. So dehydration carbocation order. So we have 3 degree, 2 degree and 1 degree. So let us draw the structure here. 2-methyl propane 1-OL. Okay. Now if you see any dehydration happens and you will get a carbocation here. This is a primary carbocation, right? Now let us see 2-methyl. So this is for option number A. Now if you see option number B, 2-methyl propane 2-OL. Now here if this one goes, we will get a carbocation here. Though this carbocation is a tertiary one which is highly stable. So the correct answer for this question will be option number B. 1-butanol will also give you primary and 2-butanol will give you secondary. Okay. So let us see the next question. The standard entropy of X2, Y2 and XY3 are 60, 40 and 50 joule Kelvin mole inverse respectively. For the reaction, this one is given, delta H of the reaction is given to be at equilibrium, the temperature will be. So the question is from your thermodynamics chapter. A very easy question. So first of all, we know the formula delta G is equal to delta H minus T delta S. Now the reaction has to be at equilibrium. So at equilibrium, delta G value is 0. So I can write delta H is equal to T delta S. The question is asked you to calculate temperature. So temperature will be delta H by delta S. Okay. So now we have been given with the delta H value already, but we need to calculate the delta S value. So how to calculate delta S value? So delta S value will be entropy of products minus entropy of the reactants. So now if you solve this one here, you can see delta S of the reaction is equal to delta S of XY3, okay, that is the product, minus delta S of reactant. So 1 by 2 delta S X2 plus 3 by 2 delta S Y2. Okay, so now we can substitute the values. What is the delta S of XY3? So XY3 value, if you let us first write down the value separately here. For X2 it is 60, for Y2 it is 40, and for XY3 it is 50. Right? I think we have substituted correctly. X2 is 60, Y2 is 40, and XY3 is 50. So I'll substitute here 50 minus 1 by 2 of X2 is 60 plus 3 by 2 of Y2 is 40. Okay, so now if I see this one, this will be 50, right, minus 30, and here we will get, this is 20, so again 60, right, so we'll get minus 40. Okay, so now we can substitute here. So delta H value is your minus 30 into 1000. We have to convert it into kilojoules, we should not forget that. And then here we have minus 40. Okay, so now if you solve this one, we'll get 750. Okay, so the correct answer for this question is option number A, that is 750 Kelvin. Okay. Next question, electrolytic decarboxylation of sodium propanoid produces. So this question is from your, I think you can tell it from acidic carboxylic acid reactions or from hydrocarbons also. This concept is there, Coles reaction. So sodium propionate is your CH3, CH2, C double bond, O minus, Na plus. So when you do electrolysis, we will get a free radical like this, right? So two such radicals will combine and we will get butane as the final product. So the correct answer for this question is option number D. Okay. Next, a compound A having the molecular formula of C5H12O on oxidation gives a compound B with the molecular formula C5H10O. So two hydrogens have been removed. Okay. Compound B gave a 2,4-dinitrophenyl hydrogen derivative but did not answer the haloform test. Okay. So from this, what first let us write in the schematic one. A, when it undergoes oxidation, it gives B. A molecular formula is C5H12O. B molecular formula is C5H10O. Okay. Now what is told about B? B gave a 2,4-dinitrophenyl derivative. So B reacted with 2,4-DNP. So what does that tell? It is a carbonyl compound, means it can be either aldehyde or it can be a ketone group, right? Now if on oxidation of a compound A we are getting B which is aldehyde and ketone, that suggests that A must be an alcohol group, right? Okay. Now if you see, but did not answer the haloform test or silver mirror test. So if it doesn't answer the silver mirror test, means it is not an aldehyde, it is only a ketone, right? And it does not give you this haloform test, means there is no CH3CO group is absent in that ketone, right? This group is absent. Okay, so that is enough. A lot of information is already given. So compound A has to be an alcohol first. So if you see, if you take this alcohol, okay, it will give you an aldehyde on oxidation, but our product is a ketone one. So this option is eliminated. Now if you see this one will give you a ketone. It is a secondary alcohol. So on oxidation you will get a ketone. But what ketone we will get for option B? That is CH3, CH2, CH2, then CO, CH3. Right? Now if you see, this contains this COCH3 group which can give you haloform test. So that is why this is also incorrect. Now if you see option number C, so the ketone produced here is CH3, CH2, C double bond O, CH2 and CH3. So this satisfies all the conditions. It is a ketone. It doesn't have any CH3CO group to show haloform reaction also. So the correct answer for this question will be option number C. Okay. Okay, next question. Okay, mark the correct Nernst equation for the given cell. So we have come to the physical chemistry chapter, that is electrochemistry, again a very important topic. So Nernst equation, always you have to write the reaction first. So Fe at anode, what is the reaction? Fe is giving Fe2 plus with loss of 2 electrons, and here I can write at cathode the reaction is 2H plus 2 electron giving H2. Okay. Now if you add these two reactions, I will get Fe plus 2H plus gives Fe2 plus H2. Right. Now next equation, if you want to write, E of the cell is equal to E naught of the cell, okay, minus 0.059 by number of electrons used is 2 log of product concentration by reactant concentration. So in product, what is there? Pressure of H2, concentration of Fe2 plus, and on the reactant side, what we have? Fe and H plus square, right? So this Fe concentration is taken to be 1, okay? So now if you see here, which option is matching? So first option, if you see, let us see here, Fe2 plus is there, partial pressure of H2 is not there. If you see option number C, here Fe2 plus is there, partial pressure of or concentration of H2 is there, then Fe is there and H plus square is there. So the correct answer for this question will be option number C. So very easy, no calculation, but basic concept based questions have been asked. Next, in the following sequence of reaction, the product is, okay, so this question is again from your hydrocarbon chapter. Yeah, so hydrocarbon chapter, if we see here, the reaction is very easy one. Alcoholic KOH will do first elimination, so we will get a double bond first. Br2, when you add, addition reaction will happen, 2 Br groups will be added. Now NaNH2 sodium amide, what soda amide? It will remove HBr and HBr. So from here one HBr will be removed, from here one HBr will be removed, and we'll get 2 double bonds. So what will form here? Right? So the main final product will be one alkyne. So correct answer for this question is option number C. Next, when propanol reacts with 2-methyl propanol in presence of NaOH, 4 different products are formed. The reaction is known as. So this question is again from aldehydes chapter. Okay, aldehydes, ketones and carboxylic acid, 4 different products are formed. 2-methyl propanol is there. So if you see what is the structure of 2-methyl propanol, so this is 2-methyl propanol and it reacts with propanol, right? So now you see there is one alpha hydrogen here, there is also alpha hydrogen here, so there will get 4 products. So this is called as your cross aldol reaction. So the correct answer for this question is option number B. Okay, next, which of the following statements is true? Okay, allyl chloride is more reactive than vinyl chloride. Vinyl chloride is as reactive as allyl chloride. Vinyl chloride is more reactive than allyl chloride. Both of them are more reactive than chlorobenzene. So if you see what is allyl chloride, this is allyl chloride where the functional group is attached to the carbon next to the double bond, and vinyl chloride is this one, right? This is allyl and this is vinyl. So now if you see, if this one is removed, we'll get a positive charge here, which is highly stable due to resonance, right? So that is why allyl chloride is always more reactive than vinyl chloride. But here if you see, if this one is removed, we'll get a positive charge on this one, which is not stable. So the correct answer for this question is allyl chloride is more reactive than vinyl chloride. Okay, option number A. So this question you can tell from your haloalkanes chapter. Next, question number 47. When 0.1 mole of cobalt, this is cobalt, okay, cobalt chloride NH3 is treated with excess of AgNO3, 0.2 mole of AgCl are obtained. The conductivity of the solution will correspond to. So this is from your coordination chemistry, Werner's theory part. Many question is asked from this topic or this concept. So now you see, if when we add 0.1 mole of this one, so what is the number of moles of complex? Number of moles of complex, coordination complex that is formed is 0.1, and we have number of moles of AgCl formed is 0.2. Then what is the number of chlorines, number of moles of chlorine outside? Okay, is 0.2 by 0.1, that is 2. So that means 2 chlorine should be outside the complex. So if I want to write this complex, I will write CO NH3 Cl and then Cl2, right? This is the complex structure. Now what type of electrolyte it is? So you have to tell in this condition like how many cations are formed and how many anions are formed. So if I dissociate it, we will get this one as one cation NH3 Cl plus and then 2 Cl minus. So it is a 1,2 type. Okay, so the condition here is 1,2 type electrolyte. The correct answer for this question is option number B. Okay, next, when solid lead iodide is added to water, the equilibrium concentration of I minus becomes 2.6 into 10 to the power of minus 3. What is the KSP for PbI2? So the question has come from chemical equilibrium. Okay, so PbI2, how will it dissociate? It will dissociate as Pb2 plus 2I minus, right? Now, if you see the concentration of Pb2 plus and the concentration of I minus, so I minus concentration is double the concentration of Pb2 plus. So, if I minus concentration is 2.6 into 10 to the power of minus 3, then what will be the concentration of Pb2 plus? So, I can write Pb2 plus concentration is half of the concentration of I minus. So, that is 1 by 2 of 2.6. So, we will get 1.3. Okay, so Pb2 plus concentration is 1.3 into 10 to the power of minus 3 and I minus concentration is 2.6 into 10 to the power of minus 3. Now, if I want to write KSP value, the KSP formula is what? Pb2 plus concentration into I minus concentration square, right? So, now if I solve this one, we will get 1.3 into 10 to the power of minus 3 and then we have 2.6 into 10 to the power of minus 3 square, right? So now if you solve this, we will be getting around 8.8 into 10 to the power of minus 9. Okay, so the correct answer for this question will be option number B, that is 8.8 into 10 to the power of minus 9. Just check the calculation once and then let me know. Okay, now let us see the next question, 49. Which of the following compound is used as the starting material for the preparation of potassium dichromate? So again the question is from DNF block. So in DNF block there is two important compounds, potassium dichromate and potassium permanganate. Okay, so their reduction, their oxidizing properties, their preparations are very important. Please revise those reactions and go for the exam. Okay, so if you see potassium dichromate, it starts from the chromite ore. Okay, so the correct answer for this question is option number C. Next question, the rate constant is given by the equation K is equal to Pz into 1 by e to the power of Ea by RT. Okay, I am writing like this so that this minus is there. Which factor should register a decrease for the reaction to proceed more rapidly? So if you see, if Ea value, activation energy is decreasing, this whole, right, this whole fraction will decrease, then e to the power of that fraction will decrease. Now if this denominator is decreasing, K will increase, right, inversely proportional, rate of the reaction will increase. So which factor should decrease? Activation energy should decrease. Correct answer is option number C. Now next, the increasing order of energies of various molecular orbitals is given below. So this question is from your chemical bonding, right? Chemical bonding, molecular theory, molecular orbital theory. So you know, if you remember, the given sequence is for the number of electrons is when the number of electrons is less than or equal to 14. Okay. Now when the number of electrons increases more than 14, there is a shift in the order. So what happens? 2pz comes front and this one comes there, right? 2pz will be coming first and then pi 2px and then pi 2py will come. So that is where the number of electrons is more than 14. So if you see, for oxygen, the number of moles electrons is 16, which is more than 14. So this will follow a different order. Correct answer for this question is option number C. So for oxygen, we cannot apply this electronic configuration. Okay. Next question, metamerism is shown by. So this is again from your hydrocarbon chapter, where we learnt about different types of isomers. So what is metamers? So for example, in ether, if we have 4 carbons, right, this is one way of writing and this is another way of writing, right? So the number of chains beside that oxygen will be different. So the correct answer for here is diethyl ether. This is diethyl ether and N-propyl methyl ether. Okay, correct answer for this question is option number A. Okay. Next, benzaldehyde and acetaldehyde can be distinguished by. So let us first draw the structure. We have benzaldehyde and we have acetaldehyde. Okay. So now if you see iodoform test, the condition for iodoform test is there should be CH3CO group, right? So here can we see this CH3CO group is present here, but that is not present in this compound, right? So iodoform test, this compound will show positive test, this compound will show negative test, and hence we can distinguish them. So the correct answer for this question will be option number A. Very easy question. Next, the property of halogens which is not correctly matched is, okay, so again we have come from P block, this question, general properties question. So ionization energy, so as we go down the group, the ionization energy will decrease, so this property is given correct. Then electronegativity, again down the group, electronegativity will decrease, so this is also correct. The density, yes, as we go down the group, mass increases, so density also increases, so the order is correct. Now electron affinity, fluorine and chlorine, here is a very important exception. So fluorine, due to its small size, okay, due to the small size of fluorine, what happens, there is inter-electronic repulsion, okay, as a result of which the electron affinity of fluorine decreases and this order becomes chlorine greater than fluorine, okay. So the correct answer for this question is option number D, okay. Now let us see the next question. If 20 gram of calcium carbonate is treated with 20 gram of HCl, how many gram of CO2 can be obtained according to the following equation? Okay, so this question is from some basic concepts of chemistry, okay, that is your stoichiometry part. So let us see now. Let us first write down the reaction. CaCO3 plus 2HCl. So question is asked about carbon dioxide, so I am not writing these all things, we can write directly carbon dioxide, okay, just to understand. So when you see 20 gram, how much is the mass of calcium carbonate given? So here this is 20 gram and this is also 20 gram. Now according to the balanced equation, what I can say, 1 mole of calcium carbonate reacts with 2 moles of HCl. If I talk in terms of mass, 1 mole of calcium carbonate is 100 gram. So 100 gram of calcium carbonate reacts with 2 moles. HCl mass is 36.5, 36.5 into 2, so that is 37 gram, right? Sorry, 73 gram. So this is your 73 gram, okay. Now that means 1 gram of calcium carbonate will react with 73 by 100, that is 0.73 gram. Now how much calcium carbonate is given in the question? 20 gram. So 20 gram of calcium carbonate requires, so we have 14.6 gram of HCl, right? Yeah, just check the calculation once. 2 3 is 6, 14, here we have 0, yeah, 14.6 gram of HCl. But how much HCl is given in the question? 20 gram of HCl is given. We require only 14.6 gram, we are given with 20 gram of HCl. Then which is the limiting reagent here? HCl is the excess reagent, then limiting reagent will be calcium carbonate. So whatever product formed will depend on the limiting reagent. So what I can say now, in this balanced equation, 1 mole of calcium carbonate, 1 mole of calcium carbonate is producing 1 mole of CO2. If I talk in terms of mass, 100 gram of calcium carbonate will give you 44 gram of CO2. Then 1 gram of calcium carbonate will give you 44 by 100. Then in the question it is 20 gram of calcium carbonate. So 20 gram of calcium carbonate will give you 44 by 100 into 20. So that is 8.8. So the correct answer for this question will be option number A. Very easy and direct question. Next question, arrange the following in the order of decreasing acidity, okay. So this question is from your alcohols chapter. Acidity order, basicity order is asked many a times, very important concept. So please understand the concept here. If we have electron withdrawing group, acidity will increase, okay, and if we have electron donating group, acidity will decrease, right? This is very simple and fundamental thing. Now you see just the compounds here. Cl, first compound is having Cl, so Cl has minus I effect, right? Then coming to compound 2, CH3 is having plus I effect. Now compound 3, NO2 is having minus R effect, and compound 4, that is your OCH3, has your plus R effect. So electron withdrawing groups are what? 3 and 1. These are minus I effects, minus like electron withdrawing groups, and out of that if you consider resonance is more effective or more prominent than inductive effect. So NO2 will be having the highest acidity. So that is your option number 3. Then we have option number 1. Okay. Now if you see these two are your electron donating groups, they will decrease the acidity. But again CH3 will be plus I effect and OCH3 will have plus R effect. Again plus R will be more dominating. So this one will reduce much, like the decrease in the acidity will be higher in case of OCH3. So the fourth one will be last and then 2. So the correct answer for this question will be option number A. Okay, very easy one but important question. Now this question 1-butane, so this is from your hydrocarbons chapter. 1-butane when heated with alcoholic KOH. Okay, so let us draw the structure. We have this 1-butane, right? Okay, so we have here the structure here is okay. So now here we have, okay, when you are treating it with alcoholic KOH. So what happens here? This H, okay, if it is removed, we'll get a negative charge here. So this negative charge is undergoing resonance and is stabilized. So what happens? This comes out as H plus. Okay. Now this bond shifts here and this bond shifts here. So I will get CH3, CH double bond, C double bond CH minus. This CH minus accepts this H plus proton and forms CH2. Okay. So the correct answer for this question will be option number A. Next question. Which of the following acids has the smallest dissociation constant? Smallest dissociation constant means it is a weak acid. Okay. So now if you see, we have this structure CH3, CHF, COOH. This is the first compound. Second compound we have CH2F, CH2 and then COOH. And the next two are bromine compounds. So if you see, the electronegativity of fluorine is more, so definitely it will stabilize more the conjugate base that is formed. So that means the answer has to be either option C or option number D where bromine is present. Now these halogens have minus I effect, and minus I effect is, or inductive effect is, distance dependent. So more near the halogen, the better is its electron pulling or withdrawing nature. Once it goes far away, the electron withdrawing nature decreases. So if you see here, bromine is present at far away, so it will stabilize less. So it is a poor acid and the dissociation constant will be the smallest. So the correct answer for this question will be option number C. Okay. Next. Okay, so this is one important question from alcohols, phenols and ethers chapter, that is your cleavage of ether. So when you have this one group OCH3, so you know this bond cannot break. So which bond will break here? This bond will break. We will get OCOH and then CH3Br. Okay. So the correct answer for this question is option number D. Next, the charges X and Y on the following complex ions are, so CONH3 whole 2 Cl4X, then oxidation state of cobalt is +3. So let us do for this one first. So we know cobalt oxidation state is +3 and then neutral, NH3 is a neutral ligand, so 4 times of 0, then Cl4 is -4, so that is equal to X. So now if I solve this, I will get X is equal to -1. So we can eliminate these two options. We have B and C. Now let us first see for this one. Fe is in +2 oxidation state. Okay. Then each cyanide ion is -1. There are 6. So that will be -6. And that is equal to Y. So we will get -4 is equal to Y. So Y value is -4 and X value is -1. So the correct answer for this question is option number C. Okay. Yeah. So these were the last 30 questions of your mock test 1 for COMEDK 2024 examination. So I hope all of you have attempted the paper. So if you have any doubt in any question, just comment it down. I'll discuss it in my next video. So and I'll be very happy if you people can, after attempting the test, can post your scores so that we can understand the level of preparedness and we can plan accordingly. Okay. So that's all for this video. So just keep preparing hard for your exam. If you have found this video helpful, please like, share and subscribe our channel. Okay. And please do not forget to join the WhatsApp channel. The link will be there in the description section. Thank you.